Welcome to this video on shifting of a graph and horizontal and vertical scaling. If this is your first time viewing a video of mine, consider subscribing if you enjoy the content. But without further ado, let's get right into this. So you're going to have two types of shifts. You're going to have a vertical shift and you'll have a horizontal shift. So let's get into the rules for vertical shifts. So you're going to have some function and you're going to add some constant k to it. K can be any type of number, right? So if k is greater than 0, it shifts up. And if k is less than 0, you probably guessed it, it shifts down. Okay, and that's all for vertical shifts. Horizontal shifts are very similar. You're going to have some function, but instead of adding some constant to the function, you're going to be adding that constant to x. All right, so we'll just say h. Remember, h can be any number. And if h is greater than 0, it'll shift left. And vice versa. Okay, so let's get to some examples here. And looking at our first example, let's just look at the function of y equals x squared. So we know what this function is going to look like. Let's just graph it out. Let's make some shifts to it. Let's go up 3 and right 2. Okay, this should be easy enough. We know for vertical shifts, you just apply, if you want to go up 3, you just add 3. If you want to go down 4, you subtract 4. Nothing too tricky there. It's your horizontal shifts that will usually give you troubles. So remember, horizontal shifts need to go inside the parentheses. And this is going to the right, so we just have to subtract 2 there. And you'll still need to include that plus 3 from that vertical shift. All right, so if we wanted, say we wanted to go left 4, it'd be x plus 4 right here. If we wanted to go to the right 3, it'd be x minus 3. So hopefully it's clicking for you. All right, let's just graph this function right here. Okay, our vertex is going to be right here, since we went to the right 2 and up 3. And mind you, this way of finding the vertex is not always going to work. This is just what I'm using right now. All right, easy that. Let's move on to the next example. All right, this example will be practicing graphing different functions that have been shifted vertically and horizontally. So we're just going to look at the graph of y equals absolute value of x. You guys should all know what this looks like. All right, and let's do some horizontal and vertical shifts to this function right here. So the first one, let's say x plus 5 minus 2 square root of x minus 2 plus 3, and last one, x minus 1/2 plus 5. Okay. So let's do this one first. And I always look at the vertical shifts first just because it's a little easier for me. So I know this is going down 2, and I know this is going to the left 5. So come here, down 2, and to the left 5 right there. And just graph the behavior of absolute value of x. Alright, let's go to this yellow one here. It's shifted up 3 and shifted to the right 2. So I'm going to go up 3 and to the right 2. That is where my vertex is. And graph the same behavior as other graphs. Last but not least, we have up 5 and to the right 1/2. So up 5, and we only go to the right of 1/2. This is a little tricky to graph. But hopefully you see the behavior of these. I usually look at the vertical shifts first, and then I'll go onto the horizontal. If this doesn't make sense, go back to the first slide of the rules of vertical and horizontal shifts. Let's move on to the next example. Alright, and now we're going to practice writing out the functions of different functions that have already been graphed. So I see our parent function here is going to be y equals x squared, and this x squared has just been shifted for every single one of those colors. So let's look at the graph or the function in the first quadrant here, this green color. So it's been shifted to the right 2 and has gone up 2. So we can just say y equals x minus 2 squared plus 2. Okay, let's look at that second quadrant there. It has been shifted to the left 3 and it's going up 1. Okay, that third quadrant has been shifted left 6. And shifted downwards 5. How about this orange graph in quadrant 4? It's been shifted to the right 3 and down 4. Okay. Hopefully that makes sense for everybody. Let's move on. Alright, now that we've gone through horizontal and vertical shifts, let's go over horizontal and vertical scaling. So there's a lot more rules for scaling than there is for horizontal and vertical shifts. We'll start writing these down. So for some constant, this is really some constant, c greater than 1, the graph is scaled by, and we will write down all the rules of which it's scaled by. Okay, so now that we set our standard here, if we have y equals c times f of x, this is stretching vertically by that factor of c. So if c was 2, it'll stretch by a factor of 2. And now we're going to have y equals 1 over c times f of x. And this is the opposite. This is compresses vertically by that factor of c. Now we're going to have y equals f of c times x. And this might throw you off. This is actually compresses horizontally. So even though C is a positive number, it still compresses. So it's going to be the opposite of the rules for vertical scaling. So this is going to be y equals f of x over c, and this is stretches horizontally. And this takes some getting used to, but once we go over through some examples, it'll make a lot more sense. Okay, so I'm just going to draw a dashed line here. Got one more thing to add to this. So for c equal to -1, if y equals f of -x, this reflects across the x-axis. And if we have y equals -f of x, this will reflect, oh, I mixed these up. This is y-axis. That's why it wasn't making sense. Sorry about that. Now this is reflects across the x-axis. Okay, and so let's move on to some examples here. All right, now that we've gone over horizontal and vertical scaling, let's go over the vertical scaling component of it, and then we'll combine all three down the road here. So I'm going to write down three different functions. We're going to have y equals the square root of x. In yellow, we're going to have y equals 3 times the square root of x in orange, and y equals 1/3 times the square root of x in green. So what does the y equals square root of x look like? I'm just going to make a quick data table for this to make things easier when we're looking at the different functions. So at x equals 1, the square root of 1 is 1. And we can go through 2, 3, and 4, but it's going to come out to numbers that aren't very nice. We're just going to plug in 4 here. Square root of 4 is 2, and square root of 9 is 3. So we're going to have the general behavior of this graph. We got 1, 1 here, 4, 2 here, and we have 9, 3 somewhere over here. Okay, so now let's move on to this y equals 3 times the square root of x. So our c in this case would be 3. So if we just look at our table here, everything is going to be multiplied by 3. So instead of 1, 1, it's now going to be 1, 3. Instead of 4, 2, it's going to be 4, 6. And so on and so forth. So let's just graph this. So this has just been stretched vertically. And if you can guess, this y equals 1/3 times square root of x, this is going to be compressed. So everything will be multiplied by 1/3. And our c, you can write it as 1/3 here. Or you can look at it as if we're just looking at the compression rule and say c is 3. You can either say this function is being compressed by a factor of 3, or it's being stretched by a factor of 1/3, which is really just being compressed. So hopefully that makes a bit of sense. So this is going to be at 1/3. So everything's going to be very, very small. It's going to look like this. Now this has been compressed. Okay, so that's all for the vertical scaling portion of this problem. Let's move on to the horizontal. write our horizontal up here, and just like our vertical scaling, we're going to have 3 different functions here. But this time, our C is going to be inside. So it's going to be affecting that X value. You can imagine that being like inside the parentheses, right? So we know what the behavior of y equals square root of x is. Has a point at 1, 1 and 4, 2. Okay, so what about y equals square root of 3x? All right, we plug in 1 there. So that's square root of 3. I am not quite sure what that is. But what if we multiply this by 3? Now we're going to have square root of 9 in there. Okay, so this is 3. What if we do 3 times 9? That's square root of 27. That doesn't really work out. Well, at least we have some point, right? I think square root of 3 is about 1.7. So we know this is going to be up here, and we know we have a point at 3, 3. So definitely it's almost looking like it's stretching vertically, right? Well, this is actually compressing. It's compressing this way. Sorry that got messy there. All right. What about this one? This 1/3 x. Once again, we don't know square root of 1/3. What if we multiply that? If we have a 3 there, so it's going to be 1/3 times 3, which is just square root of 1. So that's going to be 1. Well, plug 9 in there. 1/3 of 9 is square root of 3. So we know this one's going to be a lot shorter than the other ones. We have a point right here. And this is actually stretching. So imagine you took the square root of x, and just pulled it to the right. You're stretching it out. That's kind of how I always think about this. It's actually, your y values are decreasing. And if you just took your hand right here and just smashed it against that, it would go up. And that is why that blue graph is compressing. Okay, now let's move on to reflections. And when looking at reflections, I believe reflections are the easiest to kind of intuitively pick up when comparing to horizontal and vertical scaling. Let's take a shot at it. All right, so we're gonna have a constant function that we're comparing to of square root of x, and we know what that looks like. Now let's compare that to y equals negative square root of x and y equals square root of negative x. Okay, and remember, we are thinking about this root x as our f of x. So for this blue case, this would be like negative f of x. For this green one, okay, and just referring back to those rules and just thinking about it, any x I plug into this green function here, it's going to be on the left side, right? I can plug in 9, it's going to be negative 9. So this is going to be on the left side there. and that's going to be flipped along the y-axis. And likewise for the blue, our function is always going to be negative, so it's always going to be down here. But we can still plug in positive y values. Just kind of, if you're ever confused about these, just plug in some values and see what happens. You can usually, from there, kind of figure out the behavior of the graph and what's going on. But let's move on to some more harder examples where we're combining all these elements and trying to look at some of these graphs. Okay, and we're going to start with the function y equals x cubed. Now let's graph this function real quick. It's going to look something like this, and we're going to do different shifts and scaling and try to get the final function with all that scaling and shifting applied. Okay, so first we're going to shift up 3. We're going to shift to the left 5. We're going to compress horizontally by a factor of 2. And I'm just going to write by 2 times. And let's flip it across the x-axis. Okay, so this looks like a lot. And if you just try to go for the final function right here, go, okay, well, this is that, that's that, you're going to get really confused. It's a lot easier if we go step by step. Okay, so up 3. Okay, well, we know how to do that. Just add 3 to the function. All right, left 5. That's going to have to be inside the parentheses. It has to be x plus 5. Okay, compressed horizontally by a factor of 2 times. So this is going to be inside the parentheses. And so last but not least, flipped across the x-axis. So that's going to need to be outside the parentheses. It's all about those parentheses. Okay, and I'm not going to make, let's go through the data table and graph this. I'm just going to graph it real quick. We have a point at negative 3, 4. We have a point at negative 2, 2. And our vertex is about here. So notice how it's a lot skinnier. It's because it got compressed, right? You basically just take, or I should go like this. This got compressed. And then I got flipped and shifted up and to the left, right? All right, let's move on. And for our last example, I'm going to list out 3 different functions. Let's do this in green. And we're going to say exactly what shifts and what scaling happen to all these functions. Be 3 of them. Let's just work through this first one. So this has gone up 1. This has been shifted to the right 2. This has been stretched vertically by 2. And that for that negative sign, that is flipped across the y-axis. Ooh. Okay, so that's that. That's that. Stretch vertically. That is that. And the flipped is that negative sign right there. All right, let's move on to our next function we have here. Our next one's a doozy. We have y equals negative 5 times 10x plus 3. 1 second. There we go. And that's going to be to the fourth minus 5. And the whole behavior doesn't really matter because we're just looking, for this is really just the graph of y equals x squared and a whole bunch of shifts and scaling has been done to it, while this is just the function of x to the fourth. Okay. So let's go through this one by one. With that negative 5 right here, that's going to be down 5. With this positive 3 right here, that's going to be left 3. With that 10 right here, that's going to be compressed horizontally. I'm just going to say compressed horizontally by 10 times. What about that 5 out in front? That's going to be stretched vertically by 5. Once again, I'm just going to say 5 times. And last but not least, we have this negative sign out front, which means it's going to be reflected across the x-axis. All right. For our last example here, we're going to have y equals 1/2 3x plus 5, and we'll just square that, and minus 2. Okay, so just like the other ones, this one is down 2. With that 5, it's going to be left 5. And with that 1/2, it's going to be compressed vertically by 2 times. And that's because it's a fraction, right? That's why it's being compressed. All right, now we have that 3 inside, which means it will be being compressed horizontally. Ooh, I don't know if I could fit that in. Once again by 3 times. Hopefully everything made sense for you and you enjoyed the video and you got something out of it. If you're studying for a test or an exam, I would review the examples we just did and create some examples of your own, because that really forces you to know the rules and how to apply them, and it goes both ways. And if you enjoyed the video, please consider subscribing. It helps a lot, and leave a like if you enjoyed the video. All right, thank you everybody. Everyone have a great day.